Today, I'll be demonstrating to you exercise 11, which is immunology and agglutination reactions. In this lab, you'll learn about how to blood type, what it means to agglutinate. You should have already learned the basic structure of antibodies and the specificity behind them and all that from the ELISA lab that we recently completed. You'll also learn how to perform a blood transfusion. This is critically important in our medical industry. Mistakes in doing this could be detrimental to the patient. So it's really important for us to blood type correctly and to give the appropriate blood type that the person can accept. If you want to learn more about actual blood transfusions, you can go to the Nobel Prize-winning site that is in your lab manual, and you can play around with a simulated patient in a virtual environment, of course. And you can give various blood types to them, and you can learn basically which ones you cannot give to certain individuals. So please make use of that study to kind of practice on that. But your TAs will discuss this more in their actual PowerPoint for this lab. And finally, you'll learn about the fatal blood condition that occurs in certain mothers that are negative, have a positive baby, and develop antibodies, and then later attack their unborn child. So, but that will be again discussed with your TA's PowerPoint. So, okay, so let's dive into today. So basically, today your TAs will go over the agglutination reaction, specifically how when you use antibodies specific to an antigen, if you use it on a non-antigen, specific antigen to that antibody, you will not get agglutination reaction. So we'll talk about that, and that's actually described in your manual as a discussion or demonstration that normally takes place in the lab. So we'll go through that. But what I'm going to demonstrate for you today is actually how to blood type. So just to let you know, I'm not using my blood. I'm not using anyone's blood. This is synthetic blood. So synthetic blood is designed to behave in a similar manner as normal blood would, but of course it's not real. This is synthetic. So I have 4 blood types here. And they're just labeled sample 1, sample 2, sample 3, sample 4. And then I have 3 antiserums. So I have anti-A, anti-B, and then anti-D. Okay. So basically what we're going to do is this is the well for A, this is the well for B, and this is the well for the Rh factor. Okay. On each plate. So what we're going to do is we're going to take each sample one by one. We're going to take a drop of sample 1 and we're going to put it in A, B, and Rh. And we're going to do the same thing for 2, A, B, Rh, 3, A, B, Rh, 4, A, B, Rh. Okay, so once we have all 4 of these plates set up with the blood, we'll then add our serums. So to A, we'll add antiserum A. To B, we'll add antiserum B. And to Rh, we'll add antiserum D. Okay? So that's basically what we're doing. And then we're looking for what is called an agglutination reaction. This is more or less just clumping. So where we see clumping, it indicates that that specific antigen is present. Okay? So if you have A antigen and you have B antigen and you have nothing occurring for Rh, then most likely that particular one is AB negative. Okay? That's the blood type. So do not confuse blood typing with blood transfusion. Okay, they're related, but they're two separate concepts. Okay, so let's jump into this then. So I now have sample one, so I'm putting a drop in A, putting a drop in B, and I'm putting a drop in RH. Now we're set with that one. Now I'm going to do the same thing here. A, B, RH. Okay. And then 3. A, B, RH. And then 4. A, B, RH. Okay. So now we have all our blood samples placed in all the wells. So now we're going to take the antiserum. So this is anti-A serum, right? Antiserum. So we're going to take this and we're going to put a drop in the A of each one. A. Okay. So now that we have a drop in all the A's, I'm going to take a specifically colored toothpick corresponding to the A. So the yellow ones I'm designating as A toothpick. It's A toothpick. And then B is the blue, and then RH is the white. So let's go ahead and let's start mixing this. And I'll use a different one for each well. Okay, so this is mixed. So now what you want to do is you want to look for agglutination, right? So again, this isn't real blood, so I'm just going to put this down on the table. I don't have a beaker set up here for a minute, but if you look, I'm tipping it right now. You can see the agglutination that has occurred. You see the clumping that's right there. So this right here is a positive for A. Okay. So now we're going to do the same thing to the other three. So let's put it here. A. And then we're using a different toothpick for each one. So I'm just going to see if I can plot through this. That's how many, whatever. So we're mixing this one. Oh, you know what I could do? I could save. I know what I'll do. I mean, if you were actually doing a blood slide using real blood, you wouldn't do this. But I'm just going to flip over my toothpick, insert. Why not, right? And I'm mixing this one. Okay, so now I use both sides together. And then the last one is A. And we'll mix that up a bit. And now let's check the other one. Okay? So now this one, let's tip it. We tip it, and do we see the same sort of agglutination happening for this one? I would say no. So in this case, A is negative for sample 2. A is negative. Now sample 3, if I tip it, look at that. Whoa, you can see some clumping going on there. Oh, right? You can see on the camera at home, right? There's some clumping going on this one, so that's positive. But A positive for the sample 3, and now for sample 4, we're doing the same thing. We're tipping it, and there's nothing. Okay, so we got positive, negative, positive, negative. So right now we've only tested A for each of these. Now this one, we're going to go on to now B. So we're going to add the anti-B serum. The anti-B serum. We're going to put a drop there. Put a drop there. Put a drop there. And now we're using the blue toothpaste. There's nothing funny I can say about this. Unless you're sad to be, I don't know, because you're blue. If So anyway, so we're gonna mix it like we did before. And then we're gonna flip it over, we're gonna mix for sample 2. And now we're gonna put that to the side because we use both sides. And then mix. Well, you kind of sing that as well. I don't know. It's up to you. What if you want to do? Mix. Okay, so now we use both of. We only use one side of that. Okay, and then we're mixing the last one for B. And there we go. So we're done with our B. So now let's evaluate B. Let's see what happens. Okay. So we're looking at the first one. We tip it, and I don't know about you, but I am not seeing any type of agglutination reaction happening here. No clumping, right? So I'm going to rule this as negative. That's negative. This one, however, so this is sample 2. We tip it. Ooh, there's a lot of clumping going on there. You can see that. So that's positive. Then on this one, you probably can't see this at home. Let me get another. Remember the B blue tip. The B blue toothpick. Okay, so I'm gonna spread this out a little more if I can. I don't know if I can. I'm used to the plate. But there does appear to be clumping going on. Maybe you can see it, maybe you can't, but maybe it would help if I put a little more B in. So let's a little more B, fill it up a little more. Let's do drop. Check that out. See if that helps. Helps the situation. Okay. And next. And since we added a little more blood, oh no, actually it's still working. So here we go. So I'm tipping it, and you can see the clumping. There's clumping going on this one. So there we have it. So now we're moving on for the last one. And the last one, we are doing tipping, and we see no clumping going on in this one. Okay? So just to reiterate, sample 1, 2, 3, 4. 1 has no clumping, 2 has clumping, 3 has clumping, and then 4 has no clumping. Okay? For B. Now we're going to go on to the very last step, which is the RH factor. We're going to test that using the anti-D serum. So we're putting a drop of that in each of the RH wells. And now we're going to use the whites. The whites toothpick. Okay, here we go. So we're mixing. Okay, and we're going to mix this one. Be careful not to splash. And we're going on to the last 2. Mixing this up as well. Kind of my mixtape. Sorry. And the very last one. Okay, well. Okay, so now let's review. Let's review exactly what our result for the RH was. Okay, so we have on the first one what appears to be clumping. So that indicates a positive result for RH. So we have a positive, a negative, and a positive. So a positive for A, a negative for B, and a positive for RH. In this case, we have a negative for A, for sample 2, a negative for A, a positive for B, and then a positive for RH. Okay? Sample 3, we have a positive for A, we have a, if I remember correctly, a positive for B, and a negative for RH. And then the last one, we have a negative for A, a negative for B, and a positive for the RH. One can see that, it's pretty clear. Yeah. So now that you have all the results, it's up to you to decide basically what each one of these unknown samples are, the blood type of it. So that will be your assignment that you can submit to your TAs, and you'll get the credit for it or whatever. Not extra points, but you'll get credit for actually completing the exercise. So yeah, so that's the immunology and agglutination reaction exercise that we would have done today in lab that you're now doing. So I hope you enjoyed, and let me know if you have any questions